Hello student, I am going to explain you topic state transition matrix in this video. In unit number 5 state space analysis, there are different topics like state space analysis and its advantage representation by using different variable form. Second topic, that is solution of homogeneous state equation in that state transition matrix, that is STM, and find out this STM by using Laplace transform method. Before that, I'm just going to explain you what is state space analysis method and its advantage and your transfer function method. In transfer function method, in first two units, you find out a transfer function. In that, the two conditions are there. First one, this only applicable to linear time invariant system. And one condition is there, you apply when your initial condition should be 0. But when you observe state space analysis method, this method you can apply for the different systems like linear system, non-linear system, time invariant, time varying system, multiple input and multiple output system. In transfer function, you just apply this system for single input and single output. So state space analysis is a modern approach and also easier for analysis using digital computers. So first understand states equation for input and output, that is x of t is equals to a into xt plus b into ut, and output equation c into x of t plus d into u of t. The behavior of this state equation in these two, first one is homogeneous and another one non-homogeneous equation. When you are used for the state transition matrix for homogeneous equation, that time your equation is only a x into t is equals to a into x of t. When you multiply by using S matrix, you consider 0 initial condition. That time finally get the STM equation, that is Laplace inverse Si minus a whole inverse into initial condition x of 0. So final state transition matrix equation is equals to phi of t is equals to a into a of t is equals to Laplace transform of Si minus a whole inverse. Different properties for the state transition matrix. First one, that is phi of t is equals to identity matrix. Means simple, at initial condition t is equals to 0, your matrix is equals to identity matrix. Then second one, you can find out your system when your time t is equals to 0 at initial condition. Second property, you can find out at t is equals to t0, that means any time duration in your system. And last property, if A is diagonal matrix, then A of t is also diagonal and each element of the diagonal is an exponential in the corresponding diagonal element of the A matrix. This is short properties of your STM. That is first one, your phi of 0 is equals to your identity matrix, then phi of inverse is equals to phi minus t and your initial condition. This is important topic because in theory paper the ask in your theory question explain your state transition matrix or enlist the state transition matrix properties. Then how to find out the state transition matrix? Phi of t is equals to a of t is equals to Laplace inverse of Si minus a inverse is the equation to find out your STM. This is your Laplace method. Second one, when you find out by using a of t second method. Third method is Cayley-Hamilton theorem. In this you find out STM by using eigenvalue and eigenvector. Method 1, when you find out by using Laplace method, first you have to find out Si minus A inverse. How to find out Si minus A inverse? That is adjoint of Si minus A divided by Si minus A determinant. Again I repeat, when you find out inverse, first you take adjoint of Si minus A and then Si minus A divided by Si minus A determinant. So one example, in that A matrix is equals to 0, 1, minus 2, minus 3. First find out Si minus A. Now the given matrix is 2 by 2, so your identity matrix is also 2 by 2. Multiply by S, so first find out Si minus A. Then when you find out the your inverse, first find out adjoint of Si minus A divided by determinant of Si minus A. Then take the Laplace inverse of this. How to take Laplace inverse? Your matrix divided by your denominator polynomials for each element. So your equation is like this. In final step, you take the Laplace transform for each element. So we will get a final answer phi of t. That is your STM. Again, I just repeat in short. You have to first find out Si minus A inverse. In that, your first find out adjoint and divided by determinant. After that, take Laplace transform for each element. That is your final answer for STM phi of t. Another second one, you have to consider the zero input. Now you know that what is the equation for the STM, that is known as the phi of t. But when you consider zero input condition, that time you multiply that zero matrix to the your STM matrix phi of t, and then this equation is again multiplied by C matrix. That is your final answer for your output equation. So simple, consider the previous example, and another one, the zero matrix is 1 by 2. So in previous example, you just find out Si minus A inverse, your final phi of t by using Laplace inverse. Now second step, when you consider the zero condition, use your zero initial condition matrix, that is 1 and 2, and simply multiply this. Last step of this, when you find out y of t, in that 1 minus 1, this is your C matrix, multiply by 8, and this is your final answer, 8 into e raised to t minus 9 into e raised to 2t. And these two problems asked in theory. First one, that is find out your STM, and another one, consider this by using zero initial condition. These two topics asked in theory exam. So this is very important topic. So first you have to find out Si minus A inverse, take Laplace inverse, and when you are used for the zero input, multiply by zero matrix and then multiply by your C matrix. That is your final answer for STM. Thank you.